Okay, so now that we've gotten a little bit more information on the confusing nature of namespaces, which again we'll go over more later, let's do a couple more functions. So a lot of the code that we've been using does checks numbers rather if they're even. So we did that a lot. Why don't we write a function to do that for us? Okay, well, we can use our def, the name of the function, which I'm going to call even checker, and then we're going to give it one number as the argument because it's just going to check if one number is even. So inside my function, and remember I have to have these little colons there to tell Python we're done with this definition statement. Okay, so inside my function, what's going to run is if n modulo 2 equals 0, so remember we know that means if it's even, return true, else return false. Okay, so I just want to point out, and we'll talk about this a little more later, but you can't have two return statements. A return statement is sort of like a break. So remember how break would just like end and it wouldn't run any more of the code, so it just stopped the loop? Well, in a function, return is similar to that. As soon as Python comes across a return statement, it won't run any of the rest of the code. Return is like a break. You're done once you hit a return. But notice I do have two return statements in this function, but if you think through the logic, no matter what number you put into even checker, you will never run both the if and the else statement. So the reason why I can have two return statements is because only one will ever run. So for instance, if I said return true and then return blue, I don't know, that rhymes, this return will never ever run because as soon as Python sees the first return, it says, oh, I'm done, and it will not run any other code after it. Okay, so let's go ahead. So we've defined even checker, but remember that's just telling Python what to do if we ever ask it to use even checker. So to actually use it, we have to call it or invoke it. So I'm going to create a variable called 8 and a variable called 9, and inside I'm going to store the value returned to us by even checker when we give it the number 8. And here I'm going to store the value of even checker when I give it the value 9. And then just to show you what ends up printing out, I'm going to print both of those variables. So let's run, and Python stores our function, then it invokes it or calls it twice, and you can see it prints 8, 9, so it prints true, false. Because when we put 8 in our even checker, it returns true because it's true that 8 is even. When we put 9 in, it returns false because 9 is not even. Okay, so let's do a little bit of a harder function, or just a little bit more of a complicated one. So we're going to define the function list word counter. And the argument that it's going to take in, so the input it takes in, is going to be called L. And I just want to note here that L is just a variable, so inside of our function, we don't know yet what we're going to be putting in our function, right? So, you know, every time you run your function, your input is going to be different. It might be stored in a different variable, it might be a different list, etc. And what we want to do is just tell Python, okay, we're going to use L, this variable L, as a placeholder. So when we run the function, and actually let me show you this example since it's a little more simple. This n is just a variable, and when you give Python the number 8 to run the function with, what it does is it says, okay, well, the value of n is 8. So every time I see an n in the function definition, I'm going to replace that with the input you gave me, which is 8. So when we ran this with 8, Python said if 8 modulo 2 equals 0, blah, 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 blah. Okay. So I just want to point that out because you don't need to call the input of your function O as L. So like when you run this, we can put, so actually let me just show you before I even talk about the function. This is a perfectly valid way to run your function. Notice I just give it a list. I don't actually give it something called L, and that's okay because remember, whatever we put inside the function as an argument, Python will just use that and it'll basically say, okay, well, L is equal to this list. and then every time it sees L in the definition, it'll use this list. Okay, now let's talk about this actual function. So it says list word counter, and so I'm going to create an empty dictionary called counts, and for word in L, and remember L is just a list of words, if the word is in the dictionary already, and I think we talked about this with dictionaries a little bit, but using the in operator with dictionaries checks if a object, so in this case the word, is a key in the dictionary. So it doesn't check the values, it just checks the keys. So basically this is saying if the word is already a key in the dictionary, then find the value for that key and add 1. If it's not already in that dictionary, if it's not already a key in that dictionary, then create that key and set it equal to 1. And then we're going to be returning that dictionary when we're all done with our for loop. And this has the effect of being a word counter. So what happens is if a word is already in the dictionary, that means we've already seen it. So we're just going to add 1 to the count of the number of times that we've seen it. So if we've already seen it once, we're going to say, oh, well, now we've seen it twice. If we've never seen it before, we add it to our dictionary, and then we set the value of the number of times that we've seen it equal to 1. So when I run it with this list here, we should get a dictionary that has the word counts of all the words. And when we run it, we can see that that's what happens. So it looks like be appears 4 times, not appears 2 times, injury appears 1 time, so on and so forth. Okay, so I just want to note actually one more thing. So see how it returns counts? If I comment out this print statement and run this, Python is still run my code. So we still have the variable called myCounts that is storing the dictionary that was returned to it, but it doesn't print. So return statements do not print out results for you. So that's totally fine. And sometimes we want Python to do something without printing anything out. However, sometimes we do, especially in class, want to be able to see the output, and that's why I added the print function there. Okay, so let's talk about a slightly harder function. And what we're going to do here is actually a really simple version of like a simulation. And remember, a simulation is just like creating fake data based on some set of rules. So what we're going to do is we're going to import the random package, which we've used before. And we're going to create this dictionary called DI, and it's going to have the keys blue, red, yellow, and then zeros as the values for all of them. So we can think of this dictionary similar to our word count dictionary as the number of times we've seen blue, red, and yellow. Okay, so let's define our function. So we're going to say def random colors, and we're going to give it the argument of our empty dictionary. Okay, does that make sense? So we're going to put our empty dictionary, it's not empty actually, so put our dictionary of blue, red, yellow with all the zeros in it inside of our function so that our function can use it. And remember, I can call this anything that I want. It doesn't have to be called the same thing as this variable. In fact, I'll go ahead and change that. Okay, so what happens is we say I equals 0, and then we say while I is less than 25, so once for every single number between 0 and 25, color equals random.choice from the list blue, red, yellow. And we talked about this very briefly in one of your homeworks, but random.choice, if you give it a list, will choose one item from that list randomly. So it'll just say, oh, you give me the list blue, red, yellow, well, I randomly pick yellow, or I randomly pick blue. So essentially what we're doing here is we're randomly picking blue, red, or yellow, and we're storing whichever random choice we get in the variable color. And so then what happens is we go to our dictionary, and remember we fed it in as di2, and remember this is just a variable name, like a placeholder. It'll be whatever dictionary we feed it. And then we say, okay, di2 color. So remember, that's how we access values from a dictionary. We say the dictionary that we want it from, brackets, not the color, the key that we want to get the value from. So this line, remember, is saying, okay, from di2, whatever color we randomly picked, add 1 to its value. And just like the list word counter we did up here, essentially what this is doing is counting the number of times we randomly selected blue red, and yellow, and storing it as the values of those colors in our dictionary. And then, of course, because we don't want an infinite loop, we've got to increment I, and then it's going to go ahead and loop, 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 all the way until I equals 25. And when this while loop is all done running, what we should end up with is 25 random choices of blue, red, or yellow, and the counts of all of those in our dictionary. So you can actually see, so we can use print statements and return statements together as long as there is nothing below the return statement. So remember, return is like break. As soon as Python sees it, it will not run any more code. Okay, so what happens is it's going to print the dictionary for us so that we can see it, and then it's going to return it to us in case we want to store it. So if I go ahead and run this code right here, what's going to happen is we're going to import random. We're going to create a dictionary. We're going to define our function, and we're going to call our function. So let's see what happens. Cool. Okay. So what happens is we see that there's an output of blue, red, and yellow, and all the various counts. So it looks like we got blue 10 times, yellow 10 times, and red 5 times. But we haven't stored this dictionary anywhere. So what I can do, so remember I returned something. And so what I can do is I can say, and I'll run actually all of this again, if I want to store the value of that dictionary somewhere, what I can do is I can set a variable equal to the output of that function, because remember that's what the return function will do. And I can set a variable equal to the output of that function so that I can use it again. So when I run this, and actually let me uncomment this as well, I have the new dictionary stored in B, so I can go ahead and print B, and it'll print the dictionary that I just created. And so you can see that's exactly what happened. So it printed the dictionary once because the function told it to print once, and then it printed again because we can see now that it's stored in the variable B in case we want to use it again. Okay, so I know we're ramping up really quickly, but one more, a little bit more complicated example. So for this function, which I cleverly named really complex function, we're going to take in a list of lists. So remember we saw this, for example, when we talked about how like spreadsheets are stored, for instance. So it's a list where all of the objects inside the list are also lists. We're going to take in this variable capital D, which is a dictionary. And then we're going to take in this variable myBool, which stands for a Boolean. And remember, a Boolean is a value that is either true or false. And so what this is going to do is it's going to say for L in LIL, and remember that's just the variable that we're, of the argument we're giving it. So this is going to be a list inside of a list. And actually I did make one here so you can see what this looks like. So you can see there's a big outer list, and then inside each object in the list is another list. And it looks like all of these are words that start with the same letter, I guess. Okay, so for L in Lil, I'll call it, if myBool, okay, so remember myBool will either be true or it'll be false. So if my Boolean and the length of L is less than 5, remember length or len will tell us whether like the length of the list, how many items are in the list. So we're saying if both the Boolean I gave it is true and the length of the list is less than 5, print skipped and then continue. So let me just talk about this little part of it for 1 second. So essentially what this is doing, and the function of myBool here, is you can use this to kind of turn on and off certain options inside your function. So essentially what this does is it's saying if myBool and length of the current list we're on is less than 5. So remember when we use the AND operator, it means that both of these things have to be true in order for this entire thing to be true. Well, the way that myBool works here is if we say myBool is true, then essentially what happens is anytime the length of the list is less than 5, we skip that list, okay? So anytime we gave it the value of true for my Boolean. So essentially we said, okay, anytime that we want to skip lists that are short and the list is short, just skip that list, okay? Now, if we give our function the value of false for my Bool, then this if statement will never run because my bool will always be false. So essentially it's the same thing as turning off this part of the loop because it will never run since my bool is false. Okay, let's take a look at the rest of the function. So after that runs, and remember that'll, since it's using the continue, it won't stop the loop altogether, but it will just move on to the next list. So if that doesn't end up getting skipped, then for item in list, so for it in L, if the item is in the dictionary already, then add 1 to the count. Otherwise, create a key for that item and set the value equal to 1. So this is very similar to what we did here, right? So we check if, or actually what we did here, we check if it's in the dictionary. If it is, we add 1 to the count because, you know, we've seen it one more time. Otherwise, we create a key and set the value equal to 1 since we've only seen it once so far. Okay, so essentially what this is going to end up doing is it's going to count the frequency of the words that occur in our list of lists. Okay, and remember, if we put my bool equals true, then we're going to be skipping any list that's really short. For instance, I see a really short list here, it'll skip that. But if my bool is false, then it doesn't skip any list, and it'll just basically count the number of times words occur inside our lists. Okay, if you need to pause for a second and look over this, or even go to the code that you have access to and run it and see what how this is working, go ahead and do that. I know that functions can be a little bit complex at times, but I'm going to go ahead and move on and show you what happens when you run this function. So I have this variable called myDict, and I am creating it, and I'm saying the word hello, :0, so I'm giving it 1 key value pair, although you know what, I actually don't have to, so I can just get rid of that. And then I'm going to create a variable called list in lists, and it's, remember, a big list where each of the objects inside the list is another list. And then I'm going to call my function. So remember, until now, all we've done is define the function. We haven't actually asked Python to run it. So I'm going to say output equals really complex function, which is, as you can see, the name of our function. And I'm going to give it the 3 arguments. So it needs a list in a list, a dictionary, and a Boolean. So I'm going to give it list in list, which is the variable I just created, as its first argument, myDict as its second argument, and the Boolean true. So remember, the Boolean true means that we skip short lists because this can be true now since my bool is true, and sometimes the length of the list will be less than 5. Okay, so let me comment out this, and we will go ahead and run our code. And so you can see what happens is our function ran, and you can see that there's a print statement in our function, and since my bool was true, we did end up skipping a couple of lists. So it looks like we skipped 4 lists because they were too short. And then we get printed out, since we stored the dictionary in output, we're going to print out output so we can see it. And you can see this is what outputted. So this is the dictionary that was returned to us with the counts of all of the words from our lists. Okay, so we can also, and I'm going to leave that there actually, so we can also run it with our Boolean equal to false. So remember, when our Boolean is equal to false, if my bool and length of list is less than 5, will never ever run, right? Because this whole composite Boolean can never be true unless this is true, right? Because for an AND operator, for an AND Boolean operator to be true, we have to have both of them be true. And if my bool is always false when we give it the argument false, this will never run. So let's go ahead and I'm going to actually run both of these. And what's going to happen, and let me delete that, what's going to happen is we're going to be able to see both dictionaries and see how they're different. Okay, so when we run that, we can see this is what we already saw last time. And now we have the dictionary when we said my bool equals false. And you can actually see there's some extra words in here, and that's because we didn't skip short lists. So for instance, I don't think the word based is in this dictionary, but it is in this one because we didn't skip that short list. And we can look up here. Oh yeah, okay, so we see that this was too short, so it didn't count it when we said true, but it did count it when we said false. Okay, so that's all I have for you for the introduction to functions. Functions are a little bit difficult to grasp your first time around, so if you need to re-watch this lecture, go ahead and do that. We'll also be having another lecture on functions later, so if you're a little bit lost, make sure you're reading the book and using the outside resources that I list in your lectures, and just make sure that you know, we'll have another lecture on this. It's definitely a big topic. We have not covered everything in functions yet. All right, see you next time.